Now we're on to a really popular type of graph called the rose curves. And this is a great one. If we could have gotten to it before Valentine's Day, you could have made a bunch of these graphs for your Valentine. Okay, this is from the book. The next type of polar equation produces a petal-like shape called a rose curve. Although the graphs look complex, a simple polar equation generates the pattern. Formulas that generate the graph of a rose curve are given by r equals a cosine n times theta and r equals a sine of n times theta, where a is not equal to 0. If n is even, the curve has 2 n petals. If n is odd, it has n petals. Kind of interesting. Okay, so this is an example of r equals a cosine of n theta versus r equals a sine of n theta. So when you have an even number, what do we have here? 8. And here we have 3. So this is probably n is 4 in this case versus 3. Okay. So let's look at the graph of this. So sketch the graph of r equals 2 cosine of 4 theta. And so I'm going to plot these out here. Now I'm going to include the pi over 4s. So I'll do my theta. I'm going to do 4 times theta. I'll do cosine of 4 theta. Then I'll do 2 times cosine of 4 theta, which is the r. So let's take this out to pi. Maybe we'll take it to 7 pi over 6 and see if we see it repeat. Okay, so we'll start with 0, then pi over 6, then pi over 4, then pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Well, we may have to take it out that far. I can make another column over here if we need to. Okay, so 4 times 0 is 0. Cosine of 0 is 1. 2 times that is 2. Pi over 6. 4 times that is 4 pi over 6, which is 2 pi over 3. Cosine of that amount is going to be negative 1/2, and 2 times that is going to be negative 1. Pi over 4, 4 times that is pi. Cosine of that is negative 1, and we get a negative 2 out of that. For pi over 3, that's going to be like 4 pi over 3. Cosine of that is negative 1/2. And then we get a negative 1 out of that. For pi over 2, 4 times that is 2 pi. Cosine of that is 1. And then 2 times that is 2. For 2 pi over 3, we get essentially 8 pi over 3. So for 8 pi over 3, just to get that perspective, I got to look at that. So this would be 6 pi over 3 and then 2 pi over 3 further. So it goes over there. So it's going to be negative 1/2 for cosine. We get negative 1. For 3 pi over 4, we're going to get 3 pi. So cosine of that's negative 1. And then 2 times that's negative 2. For 5 pi over 6, that's going to be 20 pi over 6, but that can be reduced to be 10 pi over 6. So 10 pi over 6, oh wait, we can take that further, couldn't we? We can make that 10 pi over 3, not 10 pi over 6. Okay, so that means 10 pi over 3. So 12 pi over 3 would take us around twice, so we're looking at here. So that's going to be 4th quadrant. No, it's going to be over here. That's 11 pi over 3. Okay, so we know it's going to be negative 1/2. 2 times that, excuse me, is negative 1. Then pi, so 4 times that is 4 pi. Cosine of that is going to be 1, and 2 times that's 2. So let's start with that. If we need to go with more points, we will. And so we start, I'm going to call this 0.5, 1, 1.5, and 2. So we start out at 2. And given that's 4 theta, we're looking at 8 petals. We do have some symmetry, so we could build off that as well. Okay, so then we're going to, at pi over 6, be at -1. So pi over 6, -1 puts us here. So it's going to be doing this type of thing. And so let me fix that because it's not quite right. It's going to be looking like through here. Through there. Okay, it's like that. And then at pi over 4, it's going to be at -2. So pi over 4 would be right along here. It's -2. So maybe this is what, that's what it's doing there. Okay. And then at pi over 3, it's at -1. So pi over 3, it's at -1. So it's going to be back to here. So I said this said -2, didn't I? Okay, so pi over 4 should actually be out to here. And it comes back. Okay. Now pi over 2, it's going to be at 2. So it's going to come up to here. And then at 2 pi over 3, it's going to be at -1. So 2 pi over 3 is here. It's going to be at -1. So right about there. And I'm guessing it's going to be coming to -2 here. And then back to here. It's going to be coming like this. Okay. And then that's 3 pi over 4. Yeah. 5 pi over 6. Okay. And then pi over 2. So pi gives us this out here. So it's going to be coming out here and back. So right now we have half a petal, then 1, 2, 3, 4. And then if we keep going with this, we would have 7 pi over 6. And if I multiply that by 4 and then times 2, cosine that, then times 2. 7 pi over 6 is here. But it's going to put it back up here. So I believe that's going to be -1. And then at 5 pi over 4 will give us a -2. And then 4 pi over 3 should give us -1 again. So it's going to be coming out here to give us that petal. So that gives us 1, 2, 3, 4, 5 and a half. So we still need this petal up here and this petal down here and the other half of that. Okay, 4 pi over 3. And then we get to 3 pi over 2. So 4 times that's going to give us 6 pi. So it's essentially back to there. So it's going to give us a 2. So that puts us here. No. 1, 2, 3, 4. Yeah, it's here. So it comes out here like that. And then I guess it's going to be this next quadrant up here. 5, that's 3 pi over 2. Then it's going to be 5 pi over 3. 7 pi over 4. 11 pi over 6. And finally 2 pi. And this puts us back at 2. This is a -2. So that's going to put us out here, and then we finish that off like that. Okay, kind of messy. It'll look nicer if you do it on Desmos. Okay, kind of long in this video, but not really a good one to split into 2 because the topic-wise. So let's keep going. Sketch the graph of r equals 2 sine of 5 theta. 2 sine of 5 theta. So right now we know it's going to be a 5 petal because it's an odd number. So let's go ahead and take a look at this. So theta, 5 theta, sine 5 theta, 2 times sine of 5 theta. So that just tells me I'm going to scale this as 0.5, 1, 1.5, and 2 again. Okay, and we're going to go with the 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, no, 2 pi over 3, 4 pi over 5, 5 pi over 6. Pi, then 7 pi over 6, and then 4 pi over 3, 3 pi over 2, we'll just do it over here. I think we'll see a pattern by this point, 3 pi over 2. And then we'll have 5 pi over 3, 7 pi over 4. No, we're not doing the 4s. Come on, erase. There we go. And then 11 pi over 6. And then 2 pi. Okay, so we have 5 times that's 0, and that's 0. Okay, we got our first point. Pi over 6, that's 5 pi over 6. Sine of that's going to be 1/2. So that's 1. So we're going to be at 1. Pi over 3, so it's 5 pi over 3. So sine of that is 5 pi over 3 is -1. No, it is negative square root of 3 over 2. 2 times that is going to be negative square root of 3, so approximately 1.73 negative. So here we're at pi over 3, so it's going to be down to here. Looks like it's going to come out like this and come down like that. Something like that. So pi over 2, 5 times that's 5 pi over 2. Sine of 5 pi over 2 is 1, so we get 2 out of that. So it's going to be shooting up to here. Shooting up like that. 2 pi over 3, 5 times that's 10 pi over 3. I got to think about that for a second. It's going to be 3 goes into 10, so it's going to be so 3 pi over 3. No, what are we looking at? 9 pi over 3 plus pi over 3. So it's going to be 3 plus pi over 3 pi plus pi over 3. So we're looking at down here. So it's going to be negative square root of 3 over 2, so negative square root of 3. So approximately negative 1.73. So where are we? That was here, 2 pi over 3, so it's going to be coming down this way. So that's going to give us this part of it. So we may not need all these. 5 pi over 6, that's going to be 25 pi over 6. So really that's 6 goes into 25 4 times with a remainder of 1. So it's like 4 pi plus pi over 6. So that's back in positive territory though. It's going around twice up to here. So that's going to be 1/2. And we get 1 out of that. So we're at 5 pi over 6. So we're at 1. So must be coming out like that. Then pi would be like saying 5 pi because 5 times that. And then sine of that is 0. So we get 0. And then, so that's for this part here. And then I think we've hit everything. We've hit it all. Let's look at 7 pi over 6. So that's 35 pi over 6. Oh boy. Well, let's just say this. 36 pi over 6 is going to be 6 pi. So that'd be 1, 2, 3, full revolution. So we're just back off of that a little bit. So that'd be a -1. So -1/2. And then 2 times that's -1. So what we're saying is on this one here, it'd be back at a -1. So it would be back up there. No, I'm sorry, 7 pi over 6. 7 pi over 6 would be back up here. So we are starting to overlap. I believe this is going to look more like, yeah, okay, well that's good. I already exceeded the 15-minute limit. Sorry about how long this one took. Okay, so that's graphing petals. They look much prettier on Desmos.